Skill practice 1, we're going to graph r equals -4 cosine theta. This is in polar coordinates, obviously, and we're going to do this by using a table of values. So what I'm going to do is I'm going to pick a table of values with theta ranging from 0 to about 3 pi over 2. In our table, here are the values that I have listed. We're going to go from 0 to 3 pi over 2. And first, I'm going to pull the values of cosine of theta from the unit circle. Now remember that cosine is the x value on the unit circle. At 0, the cosine is 1. At theta equals pi over 6, the cosine is root 3 over 2. At theta equals pi over 4, we have root 2 over 2. Theta equals pi over 3, we have 1/2. At theta equals pi over 2, we have a cosine of 0. At theta equals 2 pi over 3, we have a cosine of -1/2. Theta equals 3 pi over 4, negative root 2 over 2. At theta equals 5 pi over 6, we have negative root 3 over 2. At theta equals pi, we have -1. At theta equals 7 pi over 6, we have negative root 3 over 2. Theta equals 5 pi over 4, we have negative root 2 over 2. And at theta equals 4 pi over 3, we have -1/2. And at 3 pi over 2, we have 0. I'm going to approximate those on my calculator. I'm going to evaluate what the actual square root of 3 divided by 2 is. But then I'm multiplying each of these values in my cosine theta row by -4 to get the r value. And I'm going to approximate the r value, let's say to the nearest tenth of a decimal. So for theta equals 0, -4 times 1 is -4. For theta equals pi over 6, square root of 3 over 2 times -4 is -3.5. Square root of 2 over 2 times -4 is -2.8. 1/2 times -4 is -2. 0 times -4 is 0. -1/2 times -4 is +2. Negative square root of 2 over 2 times -4 is +2.8. Negative square root of 3 over 2 times -4 is +3.5. -4 times -1 is +4. And then we have the rest of these values in our chart already, and so they're going to cycle through. So again, the square root of 3 over 2 negative times -4 is 3.5. Negative square root of 2 over 2 times -4 is 2.8. -1/2 times -4 is +2. And 0 times -4 is 0. Now remember, when you have a graph of -r theta, so it's actually r theta plus pi that we are graphing. For the first point that we are given, that is -4, 0, that is the same thing as +4, 0 plus pi, or +4 pi. Same thing is true for the next point, where we have -3.5 pi over 6. That's actually going to be graphed as 3.5 pi over 6 plus pi, which is 3.5. And pi over 6 plus pi, I'm going to take pi and turn that into 6 pi over 6, so that they have the same denominator. So 1/6 pi plus 6/6 pi is 7/6 pi. The point -2.8 pi over 4, using the same approach, becomes the positive r value, and then we take pi over 4 plus pi, that is 4 pi over 4, so that I can add a fourth pi plus 4/4 pi to get 5/4 pi. And then the last one we have where r is negative, we have negative 2 pi over 3. That's positive 2 pi over 3 plus pi, and that's 3 pi over 3, so that I can add the pi over 3 plus 3 pi over 3. That's 2. A third pi plus 3/3 pi is 4/3 pi. And so this is the ordered pair 2, 4 pi over 3. And then the rest have all positive r's, and we can graph those. And remember, we're not graphing any of the cosine theta, we just use that to find our r value. It was an intermediate step. So let's go to our polar graph below and start graphing some of these points. The first point that we had was 4 pi. So r had a length of 4 at theta equals pi. So I'm going to count 4 rings on the circle, and at pi I'm going to make a dot right here. So these are 1, 2, 3, that's the fourth circle. The next point was 3.5, 7 pi over 6. So I find 7 pi over 6, which is in the third quadrant, and on the fourth circle, I make a dot. The second point was 3.5, 7 pi over 6. So I go to 7 pi over 6, and I go in between the third and the fourth circle, make a dot. The third point was 2.8 at 5 pi over 4. So I go to 5 pi over 4, and I go almost to the third circle and make a dot. The next point was 2, 4 pi over 3. So at 4 pi over 3, I make a dot at the second circle. And then at pi over 2, our r value was 0. At 2 pi over 3, our r value was 2. So I go to 2 pi over 3, and at the second circle, I make a dot. At 3 pi over 4, our r value is 2.8. So at 3 pi over 4, I make a dot at almost 3. At 5 pi over 6, our r value is 3.5. And at pi, again, our r value was 4. So now we're repeating values. So all these values are repeating. So I'm going to connect this. This is a circle that is centered at 2 pi, and it has a radius of 2. Recall in rectangular coordinates that a circle has the equation x squared plus y squared equals the radius squared, or x minus h squared plus y minus k squared equals r squared if it's not centered at the origin. We can turn this into rectangular coordinates just to verify. We multiply both sides by r times r is r squared. R times negative 4 cosine theta is negative 4r cosine theta. We do know that r squared is equal to x squared plus y squared. And we also know that x is equal to r cosine theta as we were defining our polar coordinate system. So I can replace that with an x here. I can then work to complete the square, adding 4x to both sides of the equation. If I wanted to write x in some factored form, I would need to find out what the missing constant term is that I would need to add to both sides. So what I would do is consider, okay, if I had x squared plus 4x, what completes that square? And when you complete the square, you take half of b and you square it. So you take half of that 4, which is 2, and then you square it, which is 4. So that would be, I need to add 4 to both sides. So then I have x squared plus 4x plus 4 plus y squared equals 4. And in this case, now I can factor that x squared plus 4x plus 4 because it's a perfect square trinomial. And that factors to x plus 2 squared. Because remember, a plus b squared is equal to a squared plus 2ab plus b squared. And in this case, the a was x and the b was 2. Going back to my circle then, I've replaced the x squared plus 4x plus 4 with the factored form, then plus y squared equals 4. Referring back to my circle equation, this means that my circle is centered at -2, 0, with a radius of 2, which is the same thing that we've graphed above in polar coordinates.